Hi to all. In this class, we are going to see about the third multiple access technique which is used in wireless communication, which is called code division multiple access. So, the code division multiple access CDMA is one type of SSMA, which is spread spectrum multiple access, where we have two different types of spread spectrum like frequency coupled multiple access and direct sequence multiple access. So what is happening in this multiple access means they use the PN sequence, which is called the pseudo noise sequence, which is used to convert the narrowband input signal into the wideband signal before the transmission. So whatever the signal intended to be transmitted, that is considered a narrowband signal. That narrowband signal has been converted into wideband by spreading that narrowband in by using the PN sequence. That is the concept behind the code division multiple access. So here we have two different multiplexes, FH and DS, where it is frequency hubbing and direct sequence. In that, the direct sequence multiple access is called as CDMA, which is nothing but code division multiple access, where we have the multiband, narrowband message signal, that is the original information to be transmitted, which is multiplied by the very large bandwidth signal, which is called as PN sequence or the spreading signal. So all the users of CDMA can use the same carrier frequency and can transmit the information simultaneously, right? So, but each user has its own PN sequence, which is approximately orthogonal to the PN sequence of the other users. So this is the pictorial representation for the code division multiple access. Here we have the access per code. So with respect to the code, the one n number of users has been accommodated in a single radio spectrum. That is the meaning for channel 1 to channel n. So each and every channel or user has used a different PN sequence, which is orthogonal to the other PN sequence. The other PN sequence which is used by the other user. So what is CDMA? It is a multiple signals band and in the same slot, right? So each the signal uses a different code, which is called as PN sequence or the spreading sequence. So and the receiver must receive the spread spectrum code. Once they know that the PN sequence, it can able to interpret and retrieve the original information. So this is the features of the CDMA. CDMA share the same frequency either by using TDD or the frequency domain duplexing. And unlike the TDMA and FDMA, in CDMA the performance gets degraded gradually, since the number of users has been increased dramatically and improves as the number of users decreases. Then multipath fading may be substantially reduced because the signal spread over the large spectrum. And compared to FDMA and TDMA, we can have the higher data rate, high data rate transmission in very high speed in CDMA. So nowadays, in the, from the middle of 2G and 3G, we have used the CDMA technology. Since CDMA uses 4 channels itself, it can use macroscopic spatial diversity to provide soft handoff. Self-jamming is a problem in CDMA, that is an issue we have in CDMA. The near path problem occurs at the CDMA receiver if an undesired user has a high peak power as compared to that of the desired user. So these are all the features of the CDMA. This is a pictorial representation how the original data signal has been spread out into the wide spectrum by using the PN sequence. So this is the narrowband signal with the time duration TB, and it has been multiplied by the PN sequence, which is given by the chain of pulses here. So once you have multiplied the data signal with the PN sequence, you will be having the original signal to be transmitted in the form of this chain of pulses. So when compared to this narrowband signal, here the transmitted signal bandwidth has been widened, which is achieved by the XORing of the data signal with the PN sequence. So this is the another repetition of the introduction. So here this is the CDMA. So you don't please get confused between the CDMA and CSMA. CSMA is a carrier sense multiple access, which is used to avoid the collusion, or it is based on the conduction method. It is used to avoid the collusion between the constitutive users, right? That is in data link layer of IEEE 802.1. Whereas in CDMA, it is nothing but code division multiple access, which is used to accommodate more number of users by using the spreading signal, which is called as PN sequence. That is the meaning of CDMA. And here how the CDMA looks like. So you know that both each and every user has two number of channels. It is for uplink and downlink. So the reverse channel which is used for uplink has set of frequency, one frequency with different mobile stations. Similarly, the power link that is used for downlink will also orthogonal to the frequency which is F, right? So that is the meaning for the CDMA with the FDD, that is frequency division duplexing, but forward as well as the reverse. So the forward channels are orthogonal to one frequency and reverse channels are orthogonal to the other set of frequencies. So this is a two set of the implementation for CDMA, that is direct sequence and frequency mapping. And here this is a spread spectrum concept, how the original narrowband input signal has been converted into the wideband by using the spreading signal. This is the spreading or the code word which is used to multiply with the original signal which is of narrowband in order to convert that into the wideband. That is called as spread signal. And this is the concept of direct sequence spread spectrum. So once the original signal has been multiplied with the code signal, it is converted into wideband, that is a spread signal. Again in the receiver, whatever the code that is used in the spreading, that despreading same code has been used for despreading in order to recover the original information in the receiver side. And this is the FHS. So here, so the main difference between the PSS is here, the frequency. Here you see the structure of the spreaded signal. So the narrowband signal has been converted into single band of wideband frequency after the spreading. Whereas here there is a shift in the frequencies. This is frequency mapping. So frequency pattern sequence changes frequency of digital radio signal across a broadband. So the radio transmitted frequency mapping channel to channel is predetermined by the pseudo noise random way. That is the meaning for the frequency. That is the difference between DS and frequency coupling. So after it is spreaded over in the receiver, the same coupling pattern is used to recover the original information at the receiver side. So here this is the pictorial representation which explains the media problem in CDMA. Here in this example we have considered two base station MS1 and MS2 which is having the same RSS value, that is receiver signal strength. If we consider the RSS of MS1 which is greater than the RSS of MS2, what will happen? So the two signals are, if you assume that the two signals are adjacent to each other, so the band of MS1 will overlap with the band of MS2, which will create the adjacent channel interference which is given by this diagram. So here MS1 with the central frequency of F1 and MS2 with the central frequency of F2. Since the MS1 RSS is very much greater than the MS1, here the bandwidth of MS1 will overlap with the bandwidth of MS2, which will create the adjacent channel interferences. So this is the final one, the comparison of FDMA, TDMA and CDMA. So this you can read FDMA, this is the abbreviations for all the three, and here sharing of bandwidth among the different users is possible in FDMA. The sharing of only the time in terms of time, and here in CDMA we have both sharing of time as well as frequency, but in terms of the different codes. So here there is no need for code in FDMA and TDMA, but there is a need for code in CDMA. Here there is only one guard band between the adjacent channel, and here the guard time of the adjacent channels are necessary, but here both the guard band as well as guard time is also necessary. Synchronization is not required in FDMA, but there is a need for TDMA. Synchronization need for TDMA, whereas for in CDMA also there is no need for synchronization. So when compared to the data rate of CDMA, the FDMA and TDMA data rates are very low. And mode of data transfer is continuous in FDMA, whereas in TDMA it is non-continuous, and mode of data transfer is digital in CDMA. That's all about the multiple access techniques of three types, that is FDMA, TDMA, CDMA. Thank you.